and some of our product lines called TACO, which is our acronym for trust, automation, compliance, and observability. Obviously, these are not product names, they are functions within organizations. So for us, it's very important to make sure that we help organizations with those 4 core pillars to make sure that they are, that they're there. We've had some talk that the automation layer in TACO might change to AI, but isn't AI just a little bit of automation in any case? So yes, Chris, I can see there. I'm not too sure if you're there, and I can see Nkosanati, you're there as well. And Kathy's here. Hi. Yes, so hi Kathy.
Hello.
Your camera's on.
Yeah. Carl, I was hoping you could maybe break it down a little bit more into sort of simpler language as to exactly what's happened and what it implies for companies.
All right, sure.
What this, and where we are in terms of maybe remediating the issue.
Oh, sure. Okay, cool. That's fine. I'll get to your question. Chris?
Sorry, yes. Good morning. Hi.
Hi. Yes. You're just joining us for today.
Well, yes, I'm going to just listen to what you have to say. I'm sure I'll probably have 1 or 2 questions that will come up. But yeah, let's take it from, I think Kathy's got us off to a really good start. Maybe we can just build on that, yeah.
Yeah, sure. And Nkosanati?
Same here. I'd like to listen and then have questions later on.
All right, cool. So what I think I'm going to do is I'm going to share an image that is, and it's an image, and I will give attribution, or you can just mail us directly and I can send you the image as well. But I am basically going to go through a timeline of exactly what happens, because I think maybe that will explain exactly the issues that we have here. Let me just quickly share my screen here. All right, cool. So this outbreak, or the CVE, is and you can read here for yourself, but I will read this for just the fact that we are indexing this. So the executils is a collection of open source tools and libraries for exec compression format, which is used for high compression ratios with support for multiple compression algorithm, notably liblzma too, right? And then on the 29th of March, Andreas Freund, the principal software engineer at Microsoft, emailed the open source security information, informing the community of the discovery backdoor of the specific library of these 2 specific versions. And he basically tried to build SSH from source using the specific library. SSH is a secure shell, which gives you the ability to do remote connections to other Linux types of machines. And he basically saw that it's slow, right? And that was the first thing that he did, is like he had a performance impact on his side, and that led him in to go and dig a bit deeper. And the specific repository, the source code repository where this code was hosted, or the dependency of the library, you could basically just track down to these different timestamps in Git, because obviously the way that Git works, and you could see exactly where the specific user introduced specific things into the code. And so with that specific timeline, he basically added a few things here and there and so on. But the intriguing thing is that if you look when the timeline is that this process happened over the span of 2 or 3 years, right? And this is I don't want to say it's nice, but it's good to see that there is actually people that is working on open source in the public that might not have the best intentions for that specific thing. So obviously laying the groundwork there year in last year 23 in June, where he's basically adding some kind of a function. But this takes a lot of planning to start laying down the groundwork for implementing a security thing like that. So it basically gives you the ability to then leak the information that's part of it. And here's an entire breakdown of the lines of code that's basically causing the breach. and then it basically gives you the ability to see what's happening with that specific compression. So you can decrypt the specific things and then see exactly what kind of communication happens. So I'm trying to. So Kathy, this is very high level. Do you want me to go deeper for you? Would that be?
Yeah.
Would you?
Carl, I think just
Yes.
in terms of what does it mean for companies? So potentially, does this mean that when I'm transmitting information, it could be read by anybody?
Yes, it could be, but luckily that is only with that specific version of that specific compression library that was affected. And luckily, because what most companies do when they start implementing open source products is they choose a specific version where they pin a specific version. So they imagine it's a version, and we're going to use broad terms now. So imagine the latest stable version of a product is version 4, and then the bleeding edge version that is continually getting updated and things like that is a version 5. Companies sometimes try to say, okay, well, for the next 2 years or 3 years, we're going to version pin on a version 4, and then we're going to build that out and give security, make sure that the thing is stable and that there's patches available for that specific version. Now, in the case of this specific compromise, this was a bleeding edge thing. So it was right at the source. Which happens is it was almost like if you use the analogy of bottled water, right? This was bottled at the source, right? This is where the fountain comes out of the water, and you're scooping up the water directly when it comes out of the ground. There's no filtering process or bottling or labeling or whatever, putting in the entire, if we use the pipeline or the terminology of bottled water with open source, this was bottled at the source. So this was scooped out directly from there. So the only things that were really affected were things that used bleeding edge software. So that is things like, sometimes I know that there was an Arch Linux vulnerability where if you're building directly the libraries directly from the source, it was also bleeding edge versions of Fedora 40 and Fedora Rawhide, which is almost like it wasn't released software. They were in beta release cycles and things like that. So those software was affected. There was no stable software. I could say like enterprise release software was affected because it was discovered so soon. And there was obviously some Debian stream projects that wasn't released as well. It was only the bleeding edge software that people. I would say that mostly developers could have probably been affected, but I think in the situation of this has been so widely publicized. I think everybody has fixed that. The people from Canonical who make Ubuntu Linux, they were due to release Ubuntu 24.04 beta builds last week, but because of this specific breach, what they did was they decided to go in and rebuild the entire distro from scratch to make sure that they weren't affected by that specific compression library or whatever. So, and they've released their beta version, I think either this morning early or yesterday, where that specific beta release was now released with the new patched version of that specific one.
Okay. So most enterprises can rest assured that they haven't been affected. Okay.
Well, nothing. Okay, never say never, right? But what there is multiple vendor advisories available for the software that you've written, or sorry, the software that you use within your enterprise. So I think most of the vendors have released something. I've seen stuff by Microsoft as well about the specific vulnerability, and it would probably be a good thing for you to go in and see exactly the security advisories for the products that you use and see if you're affected by the specific vulnerability. Okay. Because it's just, in fact, it's good practice. If you look at the amount of critical releases this year on CVEs, I did a quick scan through the Red Hat CVE database. This was the only critical one that is listed so far for this specific year. However, there is high vulnerabilities that's continually coming through, and moderate and low vulnerabilities coming through totally also. It never stops. and for the amount of high vulnerabilities, there's about 14 for this year as well. So there is other vulnerabilities as well. So it's probably a good practice within an organization to make sure that you are consistently patched, and that you're patched against vulnerabilities or outdated software, or make sure that you have the appropriate support services in place to look after your specific software, right? And specifically, I think the industry refers to this as SBOM, SBOM, software bill of materials, to make sure that whatever you use is patched and there's no known vulnerabilities. But this is a moving target, and people consistently need to make sure that they are patched. Yeah.
Okay.
And then, Carl, what specific version of Exit are we talking about here?
There was 2 releases that was known. It will also be in that specific document. It's version 5.6 and 5.6.1.
Thank you.
And I think the big thing about these specific vulnerabilities on the source code level is that, and there's a lot of talk within the industry of paying open source developers, right? But I still think that that paying engineers for the work they do is nice, and it's good, to support people to work on their passion projects, and it's also good to make sure that these products are secure, right? And I don't want to say that this is an open source problem and not specific a vendor open source problem, but it's usually a good idea to, when you start looking at what you're implementing within an organization, and you're looking at specific vendor open source, it's great to run bleeding edge, and we understand that there is some performance benefits in that, but sometimes it is better to have a version of software that has gone through a specific QA process or release cycle, or I don't know, I don't want to say software by committee, but there has been decent software check marks in place to make sure that the version that you have has gone through some kind of a QA process or vulnerability process. Chris, do you have any opinions? I don't know what kind of industry you're working in, but it's always good to hear some divergent or different opinions or additional add-on opinions.
Gosh, no, at this stage, excuse me, at this stage, I think I'm just going through what I received yesterday and listening to the conversation. I can't really deep dive as technical as you have, but I think it's important what you're saying, and obviously this is a development that, like you said, requires the attention of the broader cybersecurity community. So, yeah, in that context, I'm going to put it together, Carl. But yeah, thank you for what you've said so far. I'll carry on listening.
Yeah, sure.
Sorry, Carl, could I ask an opinion? The fact that this vulnerability was discovered almost by accident.
Yeah.
What is the concern that there might be other vulnerabilities lurking there that people haven't stumbled across yet?
I think the big thing is that there's software in its inherent nature is that if it's not a bug, it's a feature. That's what they always joke about. But the problem is that software, anything that you add anything to time, there's some degradation that happens, right? If you look at paintings or buildings or statues, if you build something and you don't maintain it, it degrades over time, and there's some things that might creep in. That's also the case with software, is that you can't write something once and it will work forever and will be stable and secure and everything like that. I think all the components that you use within your organization, you need to make sure where they come from. Is it from a trusted source? Specifically when you're building softwares or relying on libraries, or specifically if you build in containers within your organization, sometimes these things are perceived to be black boxes. And you bring it in and you don't know what's in there unless you actively scan containers or some of the packages that you use for specific vulnerabilities. And I think it's difficult to say that open source is inherently more secure than proprietary software or closed source software. But what we can say is that at least there is more eyeballs on open source software. So software that's being developed in the open, anybody can report a problem. Anybody can see an inconsistency. Anybody can see dodgy behavior in a repository, where sometimes when we look at some closed source vendors and we get a package from them, we don't know exactly how that thing is assembled. They're not giving us the source code. They say, trust us, run this on your network. But you don't know exactly what that kind of thing is. And then if you look at there's been multiple other pieces of and vulnerabilities that have come out over the years, and I think that it being discovered by accident is a beautiful thing, because it is developed in the open. But obviously, this person is almost a subject matter expert, or this person was a curious individual that digged in deeper. And I think it is important that if you do not have that kind of personal skills, then probably the next best thing is to go for something like a vendor open source product, where you can see that there's a vendor behind it that's looking out for your best interests. And we're not saying that buying open source enterprise software is probably the best thing, but what we're saying is that having open software keeps that specific vendor accountable of what they're actually putting into that specific product, so it gets discovered faster. So it's not a thing about it being discovered by accident and what happens. It's the big thing is that how fast do you respond and how fast do you remediate? Because we all have to be agile within our organizations. Things consistently change, and how fast we respond to the change is probably the better thing. Okay. And I think also, because you're asking for opinion, and I love opinions because then they can't be held accountable. Well, instead of a court of law, right? Whatever. But what I'm saying is that I think it comes down to a specific culture thing, right? With software, it changes and evolves the whole time. There is different ways of doing software year over year. There's new best practices and new ways of doing things. And I think if you are in an industry where you allow for the culture of consistent change, and it's not a bad thing, right? Then yeah. So it's important to understand that things are going to change, and software will get outdated, and software does become vulnerable because there is smart people out there trying to do not so good things, and they are consistently looking for ways to get in.
Sure.
Yeah.
Oh, that's great. Thank you.
Sanati, do you have another question or opinion?
No, so far happy, very happy. Thanks.
Okay.
Well,
yes,
I'd like to ask something quickly. And I hope the question is kind of makes sense. But to what extent is this situation or this scenario a foundation for things to come later? Has it set a precedent in terms of cybersecurity and cybersecurity posture within companies?
I don't know if it's set a precedent. Usually behind all the vulnerabilities, there's some kind of a marketing campaign, right? A few years ago, it was Shell Shock, then it was Heartbleed, and then it was the Spectre bug, and then the Meltdown bug and the CPUs, and there's these elaborate, beautiful names and marketing campaigns and logos for a vulnerability. And you think the thing is that there's consistently vulnerabilities out there, and it's almost that the industry sometimes celebrate their finds. And I think there's good business in finding vulnerabilities. With projects like I think the Project Zero project by Google and by Apple and by Microsoft, where they basically fund security researchers to go and find vulnerabilities and then paying them, right? Where I think the thing is that that is a good thing, where we are paying security researchers to actively go and find software and consistently try and find and break things to make sure that it's stable and secure. But I think with the advent of something like AI, I think the way that these vulnerabilities and things will get injected might get a bit more obfuscated or a bit more clean, or like very undiscovered. But I don't know. Yes.
Yeah, thank you very much, Carl.
What do you think? What do you think, Chris?
Yeah, I mean, I think it's very much the way you've described it, and I think it's only going to get worse. I think I say the word worse, but I think it's going to become more difficult for companies to improve their ability to discover these things. And it's not a surprise when you say that people are getting paid to discover the vulnerabilities. I think that's a very good thing as well. But it seems to me, if take it from an abstract point of view, it seems to me that security is becoming more complicated, more difficult to control. And just as quickly as vulnerabilities are being discovered, there's other problems coming up. So, yeah, I think it's a watch this space scenario, if I can put it like that.
Yeah, I think there is a lot of, like, I would say, like the proliferation of technology within the enterprise, specifically technologies like AI. Right.
Yes.
There is people. It's obviously going to use AI for bad, and there's people going to use AI for good. And I think people are gonna. You have to consistently outsmart something. But how I feel about it, right, is that one should be careful of organizing. Well, it's gonna sound hard because it sounds like I'm shooting myself in the foot, right? But we should be wary of organizations that capitalize out of fear, uncertainty, and doubt, right? FUD. We need to understand that there is risks out there, but making sure that those risks are mitigated to a certain extent, because I don't think you can mitigate all the risks, but there's best practices that you can start implementing to make sure that these things are mitigated to a certain extent. But we have to be hopeful that the specifically within the open source community, that there's consistently people looking at what's going into distributions and in software packages and things like that. And we also have to make sure that and it will probably build bridges we'll build bridges between companies and the communities and things like that, to be a bit more transparent about how software gets built.
Yeah.
So it will definitely get harder, but technology gets better. So right, and so I think there's an offset. Things will get more complicated, but we have technology that's main purpose is to make things less complicated. Yes, Nkosinati.
Just to that point where you're saying that the good guys are also going to use AI. I mean, with this researcher, for example, who you said the first thing they noticed was that the package just took a little longer to build. And yes, the bad guys are going to use AI to make this more complicated, but someone like him also has AI that can look at that specific parameter, for example, and give a warning. So it's not as though it's a one-sided development, is it?
Yes, I think the thing is that sometimes what we do is we consistently try and look for vulnerabilities, and they say shift security left, right? So let's see what the developers are doing. Let's see how they're building packages. Let's see how they promote artifacts to the pipeline and getting releases out, right? But what I'm saying is that it's not a checkbox and then it's done, right? Vulnerability scanning and compliance scanning and those kinds of things should happen continuously. It's not a checklist to say, okay, I scanned on Monday and I'm only going to scan once a quarter because then that's when the audit findings are due, or once a year, where people are doing audits across their systems, right? I think that we should make sure that compliance is a continuous process, and vulnerability, we need to trust everything we see every day, right? It's almost saying, like, if you have a security camera at home, you only check that security camera once a year, right? The weird thing is that if somebody rings at the gate, you check immediately, if you have the camera, to go and see who's at the gate, right? Because it's a continuous thing. Or sometimes you don't even hear, you just check the camera to see what's the status. And I think it's the same thing. It's the same thing with us, is that we should have those processes in place where we have the ability to continuously make sure we're in a state of compliance. We're continuously scanning for vulnerabilities. And sometimes I think it's difficult in air-gapped environments where those things might not have connections or internet access or things like that. But it's important to make sure that we continuously know what kind of vulnerabilities we're vulnerable to. And that means that we have to check regularly or make it a habit or a practice within our organization. Chris, anything else?
No, thanks very much, Carl. I've got quite a bit here. I don't know if anybody else wants to add anything, but yeah, it's been very interesting. Thank you.
Yeah, I'm very happy. Thank you, Carl.
Anything else, Kathy?
I'm good, Carl. Thank you very much. That's great.
Okay, cool.
Awesome.
Fantastic.
Thank you.
Thank you for joining us. Let us know if we can answer any more questions. It's an ongoing topic. It's interesting stuff. Carl is heading up some cool stuff for Obsidian. So we'll continue to keep you updated, and hopefully we'll see you in person really soon. So thanks for joining us this morning. Nice to see you. Thanks, Chris.
Thank you, everybody. Thanks very much.
Thank you.
Thanks so much for setting it up.
Okay.
Thank you.
Cheers.
All right.
Bye.
Bye.
Go on.